Today we are still going to be solving trig equations, but we are going to look at ones that are a little bit more complicated than we saw on Friday. So, for example 1, we're going to solve sine x cosine x minus 1/2 cosine x equals 0. And so, one strategy that we can try for these problems is we can factor these problems out. So notice here I've got a cosine x with this first term and a cosine x with the second term. So if I can get this factored, it'll be a lot like 7, 8, 9, and 10 that we had at the end of Friday's worksheet, where those were already factored for you. So in this case, if I pull out a cosine x, I'll be left with, on the inside with a sine x minus 1/2, and this stuff will equal 0. So I can just set each one of these equal to 0. And so sine x will equal 1/2, and of course cosine x equals 0. This one does ask for principal values. Remember, principal values just restricts the part of the unit circle that you're looking for. Principal values are different for sine and cosine. So let's start with our cosine problem first. So principal values for cosine are from 0 to 180 degrees. Or I'm going to do everything today in radians. Mostly because I feel like radians are probably the most foreign and difficult for you right now. And so that'll give us a little more practice with these. You easily could just give the degree answers as well. Most everything on that trig test number 2 is going to be in radians, but there are a few that are in degrees for that one. Also, most everything on that test is going to ask for principal values. But there are a few that might ask from 0 to 2 pi, which we'll look at here in a second. So, at cosine equals 0, cosine is your x coordinate. Your x coordinate equals 0 right here, which is pi over 2. So we would say pi over 2 would be our answer for cosine of x equals 0. That is the only place from 0 to pi that occurs. You do have a cosine x equals 0 right here at 3 pi over 2, but that would not be a principal value. So for sine of x equals 1/2, we're looking for where sine, which is our y coordinate, equals 1/2. That happens right here at pi over 6. So x is going to equal pi over 6 for that one. Again, principal values, you're only looking in the first and fourth quadrant here. For principal values, you do have a value of 1/2 over here, but it's not in that interval, so you wouldn't include it. So you got two answers. You got pi over 2 and pi over 6. Okay. Any questions on that one? All right, let's keep going. So this one's definitely a little more complicated. We've got cosine squared x minus cosine x plus 1 equals sine squared x. And so you've got some issues here because you've got this cosine and you've got sine in this one. So in a problem like this, unless we can replace our sine squared x plus cosine squared x with 1, which we cannot do here because our sine and cosine are on the opposite sides of the equal sign, we typically want to change everything to sine or everything to cosine. And remember, we know sine squared x equals 1 minus cosine squared x. We learned that on Thursday. And we also know cosine squared x equals 1 minus sine squared x. So if we have sine squared or cosine squared, we can always change it to 1 minus whichever opposite function you have there. However, this cosine x right here, we cannot change it because it is not squared. So we need to change everything to cosine in this problem because there's no way we can change this cosine right here to sine. So I'm going to do cosine squared x minus cosine x plus 1 is going to equal 1 minus cosine squared x. So I'm just using that Pythagorean identity to replace that sine squared x there. Okay, questions? Alright, so I'm going to move everything to one side. So I'm going to subtract this 1 right here. I'm also going to add that cosine squared x. And this is like 1 cosine squared x plus another 1 cosine squared x, which is going to give me 2 cosine squared x minus cosine x. The 1's will cancel here, and this will equal 0. Okay, questions? Alright, so we want to factor this. Whenever I look at this, I see I've got a cosine squared and a cosine here, so I could factor a cosine out as a greatest common factor. And so that would leave me with a 2 cosine for that first term, and then just a minus 1 for that second term whenever I factor that out. And so once it's factored, it's like the problems that you guys were doing on Friday. So you've got cosine of x equals 0. You also have 2 cosine x minus 1 equals 0. And so over here, let's solve this one on the right first. So you got 2 cosine x equals 1. You divide both sides by 2. So we're looking for where cosine of x equals 1/2. Now, this particular problem, do notice up here, it said that we're solving from 0 to 2 pi. So in this case, we're looking at the whole unit circle for answers, not just our principal values. Sometimes questions ask for answers from 0 to 2 pi. Sometimes they ask for principal values. Sometimes they might even give you a different range of values to look at, but typically for me, you're only going to see principal values or 0 to 2 pi. So if I look first here for cosine x equals 0, cosine is our x coordinate. We're looking for where that equals 0 on the whole unit circle. So right here at pi over 2, we have a cosine of 0. If we continue around the unit circle, right here at 3 pi over 2, we also have cosine equal to 0. And then that'll be the only other place there. That 3 pi over 2 is not a principal value, but they told us to look at the whole unit circle here, so we're going to include it. So we've got 2 answers here. We also need to know where cosine equals 1/2. So again, cosine x coordinate, it equals 1/2 right here at pi over 3. So x is going to equal pi over 3. And then we're going to continue around, and we're looking at the x coordinates. And right here at 5 pi over 3, we also have a value of 1/2 here. So we would also include 5 pi over 3. Again, 5 pi over 3 is not a principal value, but we include it for this one since we're looking from 0 to 2 pi. So you have 4 answers for this problem. Okay. What questions do you guys have on number 2? All right, let's continue on. Example 3. We've got sine squared x equals sine x. And so I wanted to show you this problem because I wanted to show you the number one mistake that students make on this problem. And that is this. They say, oh, look, I'll just divide both sides by sine x. Don't write this down, it's wrong. And so if you do that, you get sine x equals, sine x divided by sine x is 1. And so you would get sine x equals 1 at 0. No, not at 0, at pi over 2. And again at No, that's the only place because it's negative 1 and 3 pi over 2. So you would just get pi over 2 as your answer. Here's the problem with doing this. It does not give you all of your answers. So this is not the best way to do this problem. You generally do not want to ever divide both sides by a sine or cosine function because it's going to make you lose part of your answers. So what you want to do instead here, you got sine squared x equals sine x. You're going to move this sine x over here to the other side by subtracting it. So we'll have sine squared x minus sine x will equal 0. And then like we were doing up here on the first two, we can factor out a greatest common factor there. So we could pull out a sine x. And so we'd have sine x minus 1 here inside of the parentheses. So we would get sine of x would equal 0. And we'd also get sine x minus 1 equals 0. What you see right here with sine x minus 1 equals 0, that gives you sine x equals 1, which the answer for that part is pi over 2, like we were doing over here. But if we had done the problem like I started at first, we'd miss this other answer here where sine x equals 0. And sine x equals 0 at 0, so you got x equals 0. And then it also equals 0 over here at pi, so x would also equal pi. So you would get 3 answers for this. Okay. Questions on example 3? All right. Example 4 is a little bit different. For example 4, we've got cosine x tangent x equals negative 1. We cannot set with some things you cannot do. You cannot say cosine x equals negative 1 and tangent x equals negative 1. That is wrong. Because that property where we can set each factor equal to 0 only applies whenever the equation equals 0, which it does not here. So we cannot do that. The other thing we cannot is not going to get us anywhere here. We can do it, but it's not going to get us anywhere here. We could move the negative 1 over to the other side and get this, but there's not really anything you can do with that. You can't factor it, you can't do anything, so that's not going to get you anywhere. What you can do for this one is we can use some of those strategies that we were using for simplifying our trig identities. And I know tangent equals sine over cosine. So cosine of x times sine x over cosine x has got to equal negative 1.
Does cosines cancel?
Yes, the cosines here will cancel. And so now you just have sine x equals negative 1. And that we can just look on our unit circle to solve. So if we look for where sine equals negative 1, sine is our y-coordinate. That only happens right here at 3 pi over 2. So we're going to say x equals 3 pi over 2. This question is asking for the whole unit circle. So we're going to report our answer as 3 pi over 2. If it had asked for principal values here, we would not use 3 pi over 2. Instead, we'd have to use negative pi over 2 for that. Okay, questions on number 4? Not always, but if you see you've got tangents or cotangents, or secants or cosecants, a lot of times it's a good idea to change those things to sines and cosines and try to simplify. All right, let's look at example 5. For example 5, it asks us to solve 4 sine squared x plus 1 equals negative 4 sine x for principal values here. And we've got both a sine squared and a sine. So in this case, what I want to do is move everything over here to the left-hand side. So I've got 4 sine squared x, and then we'll have plus 4 sine x plus 1 equals 0. That sign changes whenever we move this over here to the other side. And so what I want you to think of this like is if you had 4x squared plus 4x plus 1. And so if you were factoring that expression, you would have 2x and 2x, and then a plus 1 and a plus 1. All right? That would factor correctly. Your middle terms would give you a 2x. Your outer terms would give you a 2x, which would give you the 4x in the middle. So you're going to do that same thing here, but with signs. So this is going to be 4 sine x. I'm sorry, not 4. So we're factoring. In this case, we cannot do a greatest common factor like we did on the other. So we'll do 2 sine x and 2 sine x. And then we can do a plus 1 and a plus 1 here. And that factors, if we multiply it back, we'll get 4 sine squared x plus 4 sine x plus 1. And since these two are exactly the same, I could set them both equal to 0, but I'm just going to do this once. 2 sine x plus 1 equals 0, so that's going to be 2 sine x equals negative 1, and I'll divide by 2. So sine of x is going to equal negative 1/2. Okay, questions before we finish this one up? All right, so we're looking for where sine x equals 1/2 over here on our unit circle. This is principal value, so that for sine, that's first and fourth quadrant. And we've got negative 1/2 right here for our y-coordinate. So this is where we're looking at. It's 11 pi over 6, but that is not a principal value. So instead, we want to give that x equals negative pi over 6 here, which is equivalent to 11 pi over 6, but does still fall between negative pi over 2 and pi over 2. Okay, that will be our only answer for this one because both of those are the same factors. Okay, questions? Okay, for number 6, we've got sine to the 4th power of x minus 1 equals 0. So if we're solving this, we've got sine to the 4th power of x is going to equal 1 if we move that 1 over to the other side. And so to get rid of something to the 4th power, we have to 4th root it. Thankfully, the number we have over here is 1. So sine x is going to equal, with any even root, you're going to have to put a plus or minus 1. So what we've got here is we've got sine x could equal positive 1, and sine x could equal negative 1. And so when we look at that on our unit circle, we're looking at the entire unit circle here from 0 to 2 pi. Sine is our y-coordinate, so it equals 1 right here at pi over 2. So x equals pi over 2 is one of our answers. And then sine also equals 1, or I'm sorry, we're also looking for sine x equals negative 1, which happens down here at 3 pi over 2. So x also equals 3 pi over 2. So we've got 2 answers for that problem. Okay, any questions? Okay, 7 is a little trickier because it does have secants, and secants aren't on our unit circle. But we do see I've got secant squared and secant, so I could factor out a secant x. And if I do that, I'm going to be left on the inside with secant x plus 2 equals 0. So I could be looking for secant x equals 0 and also secant x plus 2 equals 0. Excuse me. And over here, this would be secant x equals -2. Now, like I said, secant is not on our unit circle, so we need to think about what we've got here. Secant is 1 over cosine of x. So, if we want to think of it like this, secant's 1 over cosine. We need it to give us a 0. Well, that's impossible to happen because our numerator is 1 and our cosine has to be a value. Even if it was 0, we'd get undefined over here. So you're not actually going to get an answer for that part of the equation. But over here, we've got 1 over cosine x equals -2. So if we think here about doing this, maybe making it a fraction and cross multiplying, -2 cosine x would equal 1. We could divide both sides by -2, and cosine x equals -1/2. We also can just think these are reciprocal identities, so if secant is -2 over 1, then cosine x is going to be -1 over 2. They're always flipped of each other. So cosine x equals -1/2 we can find on the unit circle. And cosine is our x-coordinate, so we're going to look around right here. Our x-coordinate is -1/2 right here at 2 pi over 3. So we've got x equals 2 pi over 3 is one of our answers. And then if we keep going around the unit circle, because this question asks us to look at the whole unit circle, we're looking for -1/2. Also, that happens down here at 4 pi over 3. So 4 pi over 3 would be another answer there. Okay, questions on 7? All right, so 8 is our last example that we're going to do. So for 8, we're asked to find sine squared x equals 1 minus 2 cosine x. Okay, that's fine, Selena. This is our last one. We're almost done. So sine squared x equals 1 minus 2 cosine x. So notice here we've got sine squared and we've got cosine. The cosine is not squared, so we cannot change it, but we could change the sine squared. So that's going to be 1 minus cosine squared x. And it's going to equal 1 minus 2 cosine x. So I would move everything to one side. If you subtract that 1 right there, it's actually going to cancel from both sides. I would add the cosine squared x over here to this side so that you get 0 equals cosine squared x minus 2 cosine x. And we can factor out a cosine here. And so that gives us cosine x minus 2. And then we're going to set each one of our factors equal to 0. And that, for the second one there, is going to give us cosine x equals 2. Now, if you remember about sine and cosine, they always have to be between 1 and -1. When we were looking at those graphs, our highest point was at 1, our lowest point was at -1. So this never happens. Nowhere on the unit circle do we see a cosine value of 2. So just like on that last problem, this doesn't actually give us any answers. This will happen fairly often when you're doing these problems. So the only answer we get is from where cosine x equals 0. And if we look at that, we're looking at principal values, which for cosine is from 0 to pi. And so cosine is 0 at pi over 2. So x equals pi over 2 would be our answer. Okay, questions? Okay, so your assignment for tonight is to do the rest of this worksheet. So I've done a couple on this key, but I haven't finished it yet. So you're just going to work out the rest of these problems here. They are kind of similar to the ones that we did, so if you have trouble, look back up at those. We'll go over them tomorrow if you have any questions about them. Okay. If nobody else has any other questions, you guys are free to leave, and I will see you tomorrow.